Hi everyone. We're going to talk about linear relationships here with taking an equation and making a table and a graph out of that equation. So we're going to start with the table here, and I've got it going vertically. You could also go horizontally, which we'll see in the next one. So for our table, we're going to do an x and y as our labels for our coordinates. So remember, all coordinates are always x comma y. These values you could use to make your graph if you wanted to. So looking at the equation here, all linear relationship equations are of the form y equals mx plus b if they're in y equals form. So that means that the number in front of x is the m, and the number by itself is the b. The m is how it moves, so that's what we call the slope. That's how it moves, or we call it the rate of change. And the b is where it begins. That's the y-intercept. You can think of it as where it begins. So the y-intercept happens when x is 0. So the y-intercept is when x equals 0. So for our first coordinate, we can just start with that. 0 for x and the y-intercept of -7. Again, that's where it begins at an x value of 0. Now, the 3/5 is the slope, tells you how to move. So for 3/5, slope is always rise over run, or we call that y change over x change. So what that means is we change x by 5 and we change y by 3. So what you could do here is you could change x by 5 and y by 3 and make your table like that. The problem is it does ask you to make a table from 0 to 5. So we're not actually going to do that for each box, but we are going to jump ahead. So 0 to 5, this would be plus 5 to get you to 5. And then it's 3 for every 5. So 3 added on to -7 is -4. Now to fill in 0 to 5, we just do 1, 2, 3, 4 for the x values. And we're going to use just the decimal equivalent of 3/5 to fill in the other ones. Because we could use 3/5 like we did, or we can call that 0.6/1. If you just simplify or rewrite that fraction as a decimal, and then just put it over 1 to make it back into that fraction. So really a change of 3 for every 5 is the same as a y change of 0.6 for an x change of 1. So as you go up by 1, this is increasing by 0.6 or 6/10. So that'll help us fill this whole table in. And again, it's equivalent to the 3/5 relationship. Oops, not 0.1, plus 1. But it's just a decimal equivalent that shows the x changes of 1. So if we add 0.6 to -7, that would be -6.4. Then do it again, we would get -5.8. Then do it again, we would get -5.2. And then do it again, and we get -4.6. And then doing it one more time, we get you to -4, which is what we already have, because that plus 0.6 would be -4. So we fill out the table using our equation, again, going from 0 to 5, using the slope and the y-intercept to fill those out. Now, I could just graph these points on the grid over here, but they're going to be a little bit tricky to graph. So we're actually going to do it a little bit differently. We're going to use the slope and y-intercept to graph instead. So we are going to start with this coordinate, 0, -7, which comes from the y-intercept. So on the y-axis, we're going to find -7. This is -7 on the y-axis. The y-axis is always the vertical axis. So this is the y-axis. The other one is obviously the x-axis. So there's our y-intercept at -7. And then we could jump ahead and use this coordinate too, 5, -4. It won't hurt to use that one. But let's see where that comes from. Because again, our slope was 3/5, which is the rise over the run, or the y change over the x change. So from this -7 right here, if I go up 3 boxes and over 5 boxes, I end up at that 5, -4. That's the rise over run. Up 3, right 5. Then I'm going to just keep going from this one. I'm going to go up 3 more boxes and go 5 more to the right, and that'll be our new point over here at 10, -1. And then we could go backwards from this -7 point. If it's up 3, right 5, you'd also go down 3, left 5. You just kind of make them both the opposite direction. So that would go down here, and now we've got plenty of points to use to make a graphed line. Go ahead and use a straight edge. When you graph a line, always put arrows on the ends to show that it goes forever, unless there's some real context that says you shouldn't do that. But in cases like this where there's no real life situation, there's no reason not to. And then put arrows on the ends, use your ruler, and of course label the equation on the line. Y equals 3/5 x minus 7. When we get into graphing more than one line or more than one graph on the same grid, you have to know which one's which. That's how we do one example. There's one more down below. This time I have a table that's horizontal, but same idea. I'm going to start with x and y. And let's do the y-intercept first. So 0 for x would be the y-intercept here, the b value. So 0 is going to be at 8. The slope is negative this time, negative 4 over 5. And you'll notice here how I took the negative that was out front and I just put it in the top. You could put it in the top or the bottom. You can't put it in both. I usually put it in the top because that's a little bit easier for me to think about it as going down and right versus left and up. That's kind of tricky. So slope of negative 4/5. So again, this is the change in y over the change in x. And a little shortcut to show that is this little triangle symbol. That means change, so change in y over change in x. So this means change x by 5 and change y by negative 4. So basically, y goes down by 4 as x goes up by 5. So if I were to do plus 5 to my x's, I would do a minus 4 to my y's. And that would work to fill out this table. But again, it wants us to go 0 to 5. So we're going to use that to jump all the way to the end here again. So plus 5 gives us 5 here. And then it's, for every change of 5 in x, we go down 4 in y. So minus 4 gives you 4 right here. And then to fill in the missing pieces, I'm going to just count by ones here to get my x coordinates. And then we're going to again simplify this, or rewrite this I should say, into a decimal. So this would equal negative 8/10, which again you can make into a fraction over 1 just to get the y change and the x change there. So for an x change of 1, y is changing by negative 0.8 or negative 8/10. So we're going to go down by 8/10 here every time as our x is changing by 1. A positive one, I should say. And that will help us fill in the missing pieces here. So 8 minus 8/10, well, that would be 7.2. And then doing it again, that would be 6.4. Doing it again, that would be 5.6. And then one more time, minus 0.8 would be 4.8. And then you'll notice again, a minus 0.8 there would make it a 4. So that's why that last coordinate there is 5, 4. Again, using it in different ways, using the slope in this form and then using it in this form over here. Okay, now to graph this, let's go and graph the y-intercept first. The y-intercept is at 8 on the y-axis. Here's the y-axis. So we're going to find positive 8 and put a dot right there. Our slope is again negative 4 over 5. So that's the rise over the run. If it's a negative rise, it means we're going down. The run is always going to be to the right because I'm always putting the negative in the top. If it's negative, it'll be up or down, but the run will always be positive going to the right. So we're consistent. So from this 8, we're going to go down 4. So we're going to follow this coordinate down 4 and then right 5. So try that again. Down 4, right 5, and then down 4, right 5 again. So down 4, right 5 will give us a point right here, which again matches up with this coordinate right there, 5, 4. And then doing it one more time will give you 10, 0. And that is enough. You only really need 2 points to make a line, but the more you can put on there, the more accurate it'll be when you draw it. I'm going to try and line this up as best I can. You want to go a little bit off the grid too in both directions to make sure your line is complete. No little baby lines here. I'm going to make a nice long line, arrows on the ends, and label with your equation. Y equals negative 4/5 x plus 8. And we've done it. We've graphed it and we've made a table.